This is a quick demonstration of testing the coefficient of friction of a certain material against a mating material. The test setup consists of a jack connected in line to this cylinder. Coaxial to the cylinder is a load cell right here. Mating to it is an adapter that's a conical shape right here, which then presses against the surface. The load is read out right here. Each mating material is on a steel backer plate. They're installed right here, and in between them is the mating surface. All this is placed directly under the head of this tensile machine. This large cylinder extends, which presses this entire test table up and presses up right here, and then this forces this plate down, and then you're able to read off the results of the resistive force through the data acquisition right here. So here's the fixture with the plates installed right here. You can see the plastic material is right here, and here's the center plate that they're mating against. It's suspended 1 inch up above the surface to get the travel. So when this is lowered, it'll travel 1 inch until it hits the test bed right here. I have centered all of this by marking the center locations vertical and laterally, and then outline them so that I could set it up correctly. There are the markings, so everything's in line with each other. It's important that they're in line, otherwise this plate could be in balance and this could slip out. These have also been squared up so that the distance from here to here is very close between all four corners. So the test fixture is underneath the tensile machine head right there. So I don't have any load on the cylinder right now, so I want to go ahead and tear this out. So I put a small preload on the cylinder and then put the spanner plate to span the bottom hole right here. That way it can make contact right here and over there when it's pressed down. So right now I have it preloaded slightly, just enough so that the plate will not slide down with gravity. Here's the calibration curve for the load cell that I did before setting the test up. So I put known loads 2 different times to make 2 different curves. And here's the conversion from the readout units to pounds from the tensile machine. So using this curve, I could just put a load here, say 20,000 pounds, and the readout will be this. So then I just use this to equate it to a force. So as a demonstration, I'm going to load it to 10,000 pounds. So the readout is 2.26. So here's the readout. I have it close enough, it's at 2.31. So here's the side view. You can see the little space right there because it's a conical surface and everything's in line. So I've powered up the machine. I want to go online. Say OK. So it's going to connect to all the load cells and the pressures in there. So here I have my test setup. I've set the program to lower until there's a preload of say 50 pounds, I think. At that point, it's going to start collecting data and continue to pressurize the cylinder upward until it reaches the approximately 1 inch of travel. Once it reaches a load of about 3,000 pounds, it's going to stop the test and then return to the starting position, and then I'll have my test curve. So now I'm going to run a demonstration test. So it's getting close to the full length of travel. And that's the end of the test. And now it's returned to the starting position and the test is over. At this point I relieve the pressure in the jack, which reduces the force right there. Then I have to reset by taking the fixture out and then repositioning the plate for the next test. Here's the improved design. This spacer allows this plate to be always set at a fixed distance the same time every time. And these V-blocks position the cylinder and the load cell at the same correct height every time. And this bottom piece allows for a little more travel since I didn't want to move these holes up. This is the only option to move the entire fixture up and just lose the 1/4 inch. It's fine because the curve flattens out well before the reduced travel because of this. So now this is set up for a full one-man operation. So I would set this up, put this in here, bump up the pressure, then I could slide this out, and then I could slide the fixture underneath the tensile machine. The other improvement I'm going to do is put some low friction PTFE underneath this bottom plate. That way it'll slide, because otherwise there's more friction at this surface compared to this surface, so this fixture slides right here on the wood instead of the entire fixture sliding.